Hello, this is Mr. One, the part 4, the final part of the Algebra 2 DCA 2 test review. We just finished 17, so now we're going to 18. 18, identify the following characteristics for each. On the left, we have a absolute value picture. It's a V. The action for domain. Domain's left to right. Well, it goes left forever, negative infinity, open. It goes right forever, positive infinity, open. Or you can say RO numbers. Range is low to high. It goes down low forever, negative infinity, open. Goes up high, the Y. 7's the highest, closed. Or you can write Y7. Since it's the second number, it's less than or equal to the second number because it's closed. As for min value is the very bottom of the picture. You can tell the exact number from the bottom, that's the answer, but there is no bottom, it goes down forever. So there's no min here. No min, no minimum. It says max value. Max is the highest value. Well, there is a top of this picture. The top of V is at -47, but the value is the Y part. So there's the max. The max value is 7. So basically, we're talking about our range. Alright, so if you can't go above 7 because that's the highest. If you're above 7, that means 7 wasn't the max. Same idea for the second one. This second picture is a quadratic. It's a U. Again, domain. It goes left forever. It goes right forever. Infinity is always open, or all reals. Range, low to high. Here, the lowest is -5, and that's closed. It's always closed unless there's an open circle. The highest is infinity. There is no top. Or you can write Y. Non-infinity number is -5. Since the number's first, it should be greater than or equal to the first number. Greater than the first number, less than the second number. It should be bigger than the lowest, and less than the highest. Minimum, is there a bottom point? Yes, that's the 2, -5. There's the minimum. What's the value? The value is the Y part. So there's a min value of -5. Is there a max value? Is there a top? There is no top. It goes on forever, so there's no max. Alright, so that's 18. 19, using the correct math vocabulary, talks about the transformations. Transformation means AHK, so it should be really easy. Involved for going from f of x to g of x. Well, I see the negative. Negative means it's reflected over x axis. The 4 is more than 1, so it's going to be a vertical stretch by a factor of 4. That -5 is my h. That means opposite though, so it's going to go right. I'll say I'm using the correct word. I'll say shifted or moved. I'll say shifted. Shifted right 5 units. That k, that +3, that's up. So it's going to be shifted up 3 units. That's it. We talk about A, flipping and stretching. We talk about H, right 5. We talk about K, up 3. That's it. Make sure you use the correct vocabulary. Reflect over X. Never reflect over Y. And then vertical compressed is the one that's less than 1. Before it's greater than 1. H is opposite, K is normal. Alright, 20. Simplify each. Hopefully you know how to do square root of 64, but if you don't, you can just do the tree branch method. So we're going to figure out what times what's 64. I'll say 8 times 8. 8 is going to be 2 times 4. 4 is going to be 2 times 2. Same over here. 2 times 4, 2 times 2. I'm going to find pairs. So here's a pair of 2's, here's a pair of 2's, here's a pair of 2's. So pairs always go outside the square root. So the first pair, a 2 goes out, only 1 goes out, the rest disappear. Second pair, 1 goes out, 1 disappears. Third pair, 1 goes out, 1 disappears. There's nothing left over inside the square root. There's no unpaired numbers, so that's my answer. 2 times 2 times 2, it's 8. Which hopefully you knew the square root of 64 is 8. But if you didn't, you could just show the work like that. The harder one's over here. Square root of 34. Well, 34 is 2 times 17. And that's it. There's no pairs, so it means they stay inside. They multiply back together. That makes the square root of 34. You cannot change that. That is unfactorable. It's prime. Now, what if you get a negative square root of -28? Remember, if it's square root of negative, that's I. You take an I out right away and make it look like a positive. Then you do the same thing from 4. 28 is going to be a 2 times 14. And then 14 is a 2 times 7. Now I do my pairs. So I see a pair of 2's. So a 2 will go out. 1 disappears. That 7 has no pair partner. Stays inside the square root. Don't forget the I in front. Whatever's in front multiplies. I times 2 is just 2I square root 7. So the hardest one's over here. Square root of -8 times square root of 20. Well, you could put back square roots can multiply square roots. I'm going to do this. It might be easier. I'll multiply them together. It's going to be square root of -160. Alright, make it one single square root, then I'll break it down into the tree branch method. So I use one they gave me. We know it's, well actually, before I even do that, let's take out the I. So this turns into I times square root of positive 160. Now 160, we know it's 8 times 20. That's the easy one. 8, again, is 2, 4, 4, 2. 4 is 2, 2. 20 is 4 times 5. And 4 is 2 and 2. We're doing the prime numbers. Find all my pairs. I'm going to start with them. Here's a pair of 2's. Here's another pair of 2's. And that's it. So a 2 goes out, 1's gone. Another pair, 2 goes out, 1's gone. That remaining 2 and 5 stay inside. And do not forget the I in front. So I times 2, that gives me 4I. And inside 2 times 5 is 10. That is the answer there. Alright, so that's good for regular. Pre-AP, keep going. GT, keep going. 21. Given the following matrix and the value of the determinant, find the value of x. Well, to find the determinant, we have to find the equation. It's going to be a times d, the lower diagonal. X times x is x squared. Minus b times c. X times negative 3 is negative 3x. Equals 10. When you subtract a negative, that's really positive. This is really x squared plus 3x equals 10. You'll see that this is a quadratic equation. You solve it by a lot of different methods. Your choice. You have 3 choices. You have factoring, completing the square, hopefully you don't do, and quadratic formula. But if you do factoring or quadratic formula, you must have it in standard form. I have to move the 10 over. And right here, I hope you'd factor because that's the fastest. I can do the guess and check method. All we get x squared is x times x. 10 is 2, 5, and 1, 10. I'll try 5, 2. If I check, I guess that's the O is 2x, the I is 5x. Can 2 and 5 make 3? Yes. 5 minus 2 is 3. Alright, so using 5 and 2, it's positive 3. So the bigger number has to be positive, the 5 has to be positive, and the 2 has to be negative, because 5 minus 2 is positive 3. Check the L and multiplication. 5, positive 5 times negative 2 is negative 10. That's good. Fully factored. Solving means you set equal to 0. So the first thing equals 0, or the second thing equals 0. I solve it. This, I subtract 5 both sides. Done. I add 2 both sides. I'm done. There are 2 answers here. Both of them will make the determinant true. You can plug them in check, but there's 2 answers. You could do in quadratic formula. You got the same 2 answers, negative 5 and 2. Would have been a little more work. If you did the x method for factoring, you still get the same x was 5, x minus 2. System equals 0. Solve, get the same answers. Alright, 22. On the graph below, f is f of x and g of x. If g of x is supposed to be the inverse of f of x, what do we need to do to fix it? So if you look, f of x is a square root graph right here. And then g of x is a quadratic graph. Remember, square roots quadratics are almost inverses. You gotta be the same picture, but there's sometimes either too much or too little. So how do I get an inverse? An inverse has to be a reflection of the line y equals x. Has to be over this diagonal line. Well, I only need this part right here to be the inverse. This left part right here, I'll just go, is not needed. It's too much. I don't need the full u. I only need half of the u because the square root is half of a u. I only need half of u. I'm gonna get rid of this part. So all I say is we only need I'll say for g of x, only use the x is greater than 0 part. Alright, so we're using the positive part. For the bottom picture, same idea. Now I'm calling n of x and m of x. If n of x is the inverse, what do we need to do to fix it? So here m of x, again, this is a square root, but this time it's upside down, it's flipped. Alright, so there's that. I need a reflection of the diagonal line y equals x. Right, well, if I flip it over, I need this part. Because if I fold it on top of the diagonal line, they should overlap perfectly. I don't need this right part. So I'm going to take this right part out. If I don't need it, I'm going to say for n of x, only use the negative side. The side less than 0. X is less than or equal to 0. Alright, so you just fix that. If they went backwards, if they start out with the quadratic and they turn to the square root, you just have to use both the positive and negative version of the square root because you have to use a full u. So if it starts as a u, you use it ends as a u. If it starts as a square root, like half of a u, it ends as half of a u. Alright, so let's do a small fix. Just get rid of half a picture by restricting the domain. 23. Solve that. Pretty simple. Quadratic, lots of forms. I'm gonna get into standard form. I'll move everything one side. I'll put in the correct order. I'll start 9x. I want ax squared plus bx plus c equals 0. Here you need quadratic formula, or you can factor, or you can x method, or you can complete the square. I would do guess and check, my favorite. 18, there's a couple options. 118, 2, 9, 6, 3. The closest ones are 6 and 3, so let's try 6 and 3. And this might go wrong, but can we guess and checking? Oh, 2 is nice. 2 is only 2 and 1, so I'm trying 2 and 1 or 1 and 2. Let's see, 6 times 1 is 6, 2 times 3 is 6. Can 6 and 6 make 9? Nope. That's wrong. That's 2, 1, I'll try 1 and 2. 6 times 2 is 12, 1 times 3 is 3. 12 and 3 make 9, yes. 12 minus 3 is 9. So I got my numbers, I need my signs. So looking at 12 and 3, I need a negative 9. Since the 9 is negative, the bigger number, 12 has to be negative. So there's the negative 12. And negative 12, you have to add 3 to get negative 9. I check the multiplication for the L. Positive is negative, we're good. Fully factored. Now I'm going to solve. It said both equal to 0. To solve the first one, I'm going to subtract 1, then divide by 6. Second one, I'm going to add 2, then divide by 3. And that's it. You can plug and check, but it'll make the equation true. 24, solve this. It's a square root. Remember, 2 are square roots. Use square powers. They're opposites of each other. I'm going to square both sides. Square root, square power, cancel out. Is just the inside, 2x plus 7. 9 times 9 is 81. Regular algebra, so I'm going to subtract 7. 2x equals 76. Nope, 74. Alright, then divide by 2, x equals 37. You can plug in check, but that will make it true. Because 2 times 37 is 74 plus 7 is 81. Square 81 is 9. 9 equals 9. That's true. Alright, 25. Last question. Solve, but give the extraneous solution. So here's the weird one. So we're going to solve like normal, like last one. You're going to square both sides. Now be careful here, because the right side, you have to do something special. So this left side is easy, 2x plus 12. The right side, you have to FOIL that. That is x plus 2 times x squared. You cannot distribute the exponent because that's not a single term. So if I FOIL this, I double distribute. I get x squared plus 2x plus 2x plus 4 equals this thing on the left side. Combine like terms. So this would be x squared. Here's 2x makes 4x plus 4. This equals 2x plus 12. Now we're solving. It's quadratic. We need standard form. Get everything on one side. So I'm moving to the right side. So I'm going to subtract 2x both sides. So 12 equals x squared plus 2x plus 4. Subtract 12 both sides. 0 equals x squared plus 2x minus 8. Right now we have a couple choices. We can do quadratic formula or factoring. I would factor. So let's see. The nice thing, x squared is only x and x. 8, we have a couple options. We have 1 and 8, 2 and 4. I'll try 2 and 4, the closest ones. Let's see, my O is 4x, my I is 2x. Can 4 and 2 make 2? Yes. 4 minus 2 is 2. I need a positive 2, so the 4 has to be positive, the 2 has to be negative. I check the L, negative 2 times positive 4 is negative 8. We're good. I set them equal to 0. X minus 2 equals 0. X plus 4 equals 0. I solved this by adding 2. Solved this by subtracting 4. Got my 2 answers. Well, you must check here, especially when it's square root. So when I check, I'm plugging to, let's see, I'll plug in the left side. Let me go black. All right, so this means square root of 2 times 2 plus 12. That's going to be square root of 4 plus 12. That's square root of 16, which is 4. On the right side, 2 plus 2. That's 4. That's true. All right, so that's good. That is the real answer, but that's not the only one. Is to find the extraneous solution. So we're going to plug in the other one. If I plug in 2 times negative 4 plus 12, that's going to be a negative 8 plus 12. That's going to be a square root of 4, which is 2. On the other side, it'll be negative 4 plus 2. That's negative 2. 2 equals negative 2. That's false. Since it's false, we don't use this. We cross it out. But the weird question is, it says, what's the extraneous solution? So extraneous is negative 4. That's the answer they want. And that's the whole DCA. Good luck. See you in class. Have any questions? Bye.